Hi everyone, it's Coach Fred, and today we're going to be talking more about linear functions, and specifically about word problems. So there's going to be two videos. One's going to be just some basics, and then the other one's going to show you some other ways you can write equations from word problems that are linear. So let's talk about these linear equations. We often are going to have to interpret linear equations, but usually we're going to be asked to interpret specifically in slope-intercept form. So you might remember that this is called slope-intercept form, and I actually call it slope Y-intercept form because there are two intercepts, and it's providing me with the Y-intercept. Now I want you to really think hard, but that M right there is the slope or the rate of change. Okay, so the slope or the rate of change. It can go up or it can go down. But it is something that is, I call it in a word problem, the changing value, okay? The changing value. And usually it's pretty easy to see what is actually changing. B, you've learned, is the y-coordinate of the y-intercept. So we'll say y-intercept right there. And in word problems, linear functions, the y-intercept is typically the starting amount, the beginning, the initial value. Okay. Now I do want to show you one thing. Sometimes we don't always write it in y equals mx plus b, but we could trick you by writing it in y equals b plus mx. So make sure when you're looking at the slope, that the slope is always the coefficient of the x term. It's right in front of the x. So be really careful. Don't jump to conclusions. Okay, so I drew a line here for you because I want to make sure that we see where everything is on this. So right here, again, this point is crossing the y-axis. This is your y-axis. This is your x-axis. So this would be 0, b. So that would be your y-intercept. The slope would be the rise over the run, the change in y. So change in y over, so this way in this case, change in x in this case. So I'm going down and to the right. Now, what's also important is this point right here. That point is the x-intercept. And that's going to have a coordinate x, 0. And it's going to be important as well. So when we're talking about interpreting these linear functions, the y-intercept is going to be important, the slope or the rate of change is going to be important, and the x-intercept is going to be important. So let's take a look. Here we have, you're buying a $1,100 computer, but you have to purchase it on layaway. Layaway is like an old term. It just means you're gonna pay it over time, okay? So you make a $250 deposit and then make weekly payments according to the equation A at t equals negative 50t plus 850. Where A is the total amount you owe and T is the number of weeks. Now I'm hoping you're familiar with that function notation. We learned it as f of x, but I could use any variable I want here, okay? So A of t is acting like my y, and y equals mx plus b, okay? So if I rewrote it, it would look like this, okay? So what is the original amount you owe? Well, remember we said in slope-intercept form in y equals mx plus b, our starting amount is the y-intercept. So in this case, my original amount would be $850. It's no harder than that. The slope, what's your weekly payment? The slope is the rate of change. So this is actually saying for every 1 week that passes, I'm paying $50. So my weekly payment is $50. All right, then it says graph the model. So I want you to think about that for a second. What quadrant would this have to exist in if we're talking about paying off something? Well, most real life examples, most, not all, but most are gonna exist in quadrant 1. So I'm actually just gonna draw quadrant 1. And I'm gonna list, this is the time or the number of weeks, because that's what it said X was or T was in this case. And A is the amount you owe. So I know I started at 850 right up here, and I know I'm going down a certain amount, and eventually I'm going to get here. All right, so the slope is the weekly rate of change. The 850 is the starting amount. This right here, what would that represent? That's the x-intercept. Well, if we think about it, that's the coordinate point x 0. So that point is going to be when you have paid off the card or the computer, the bill. Means when you owe nothing. So that point is going to be important to us, okay? All right, let's look at another one. Example, you're interpreting from an equation. Elizabeth's been paying her credit card bill since January 1st. So here's a MasterCard. The equation B equals 675 minus 100M represents the relationship between the time she's been paying the card, which is M. Time is really going to always be that variable. And the amount of her card B. Now this time I didn't use function notation. I just used different variables. Now you might notice this is in the form y equals b plus mx. So my slope is 100 and my b is 675. So how much did Elizabeth owe at the beginning of the year? All right, let's recall. Our y-intercept is our starting amount. So take a guess and then I'll come back and tell you. So our beginning amount would be $675. Now I could also ask you, how much does she pay each month? She pays $100 each month. That's our rate of change. That's the changing value. She's changing every month. She's paying $100 more. All right. I could ask you to write an equation with this information in slope-intercept form. So let's look. Aminata joins a new movie service called Hulu. She pays $15 for the membership and $3 for each movie that she buys. Write an equation in slope-intercept form that models the relationship between the cost she pays, Y, so they're telling me that Y is my cost, and the number of movies she buys, which is X. Okay, so we want something in Y equals MX plus B. So we need our changing value and our starting amount. Well, it looks like our starting amount is 15. That's the amount she pays just for the membership. And for each movie, that for each is telling me a rate of change, she's paying $3. So let's think about this. Y equals 3x plus 15. She pays the $15. And then for every one movie, she pays $3. And if you think about a slope as like 3 over 1, right? The amount per movie. Okay? All right, the last one I'm going to talk about in this video is asking you to interpret everything you might need to know. So here we've got this question. Laura lights a candle in her kitchen. The height of the candle is represented by the equation y equals negative 1/2 x plus 6, where x is the time in hours the candle's been burning. So x is time in hours, and y is the height of the candle in inches. What does the negative 1/2 represent in the context of the problem? So again, it's the rate of change. So for every hour that passes, the candle decreases 1/2 inch. Does that make sense? Is that the changing value? Yeah, it's going down 1/2 inch every hour. What does the 6 represent in the context of the problem? Well, this is y equals mx plus b, so that would be my starting amount. So the original height, the candle was 6 inches high. When it was lit. All right, so now it asks us, what does 12,0 represent in the context of the problem? So I'm going to draw that. Okay, so I'm drawing quadrant 1 because this is a real life example which makes sense for it to be in that form. X is hours. Y is height of the candle. I'm going to label. So I started up here at 6 inches, right? I went down 1/2 inch per hour until I got to here, 12,0. So 12,0 is when the candle has burnt out. All right, guys, that's just a little about how you interpret a linear function. I hope that was helpful for you. If you need to go back and listen to it again, absolutely worth it. That's the nice thing about having a video of your lesson. Have a great day.